Okay, so so I spent the last 2 days at Imperial College at the Maple TA bootcamp. Now apparently Maple TA is now called Mobius. It's going to take us a while to get used to these new things. So I just wanted to show you some of the new things. So I mean, I already had a reasonable amount of experience with Maple TA. So the first day was just interesting to see what other people have done. So the kind of one of the things I wanted to look at was to see if we could actually convert some of the experimental lab sheets and into Maple TA, because actually if we look at one of these lab sheets, this is one of the experimental labs. So this is just measuring the density of solids. So the students work in groups. The groups are pretty fluid. I signed this to stop plagiarism. I actually signed the sheet. This is actually the Mansell system, and this just helps with cutting down on plagiarisms. So the idea is in the sheet you do some measurements with a kilometer dimensions of the object. You weigh it, and then you compute a little table. And then there's another bit where you measure the water displaced. And it's all a question of just doing some simple measurements and then converting units. Okay, fine. I mean, this doesn't take too much work. It doesn't take too much, in principle, it doesn't take too much work, but I find I spend essentially a week marking these things. And all the time it's very boring. A lot of the problem is dealing with all the groups stuff at the top, because not all the group members turn up to every class. If I have 2 members, sometimes I have informal groups, and there's just kind of a lot of admin to just deal with the marks, and then I have to I have a system for coordinating the marks over different things, a kind of Python-based system. So what I learnt is actually at Birmingham, they have a site license with Maple TA, and they're actually using it for some of the chemistry labs. Because he said actually chemistry labs are actually more structured, so it is very much like a checklist, because obviously if you're dealing with explosive stuff, this is very difficult. So I kind of focus on the Maple TA stuff. So here I'm trying to start the same thing. One of the issues with Maple TA is very geared up to a single user. So you just have one student submitting, and somehow I need to fake in a similar system, that I can pull out the students' names. But the rules say I'm allowed to create names for labs, apart from the anonymous marking. So one way to do it would be to kind of fake it. This is a Maple TA input box. So this is something I built. You can insert pictures, so somehow the Maple TA would actually be a kind of interactive worksheet. And then I kind of lost a bit of energy. Here's the material dimensions, and I tried some slightly different formats, it's maybe too long. There's and down at the bottom, so I had this thing about plagiarism. One of the issues with these online systems, I have to just make sure, I always have this worry that people will just copy measurements of each other, and you can actually upload a file here and attach it. So some of these things can be sort of, if I write the code correctly, can be marked automatically with a single deadline, and this will hopefully cut down the my time spent doing all this kind of tedious stuff for a week. And then I can look at things like this to make sure that the actual group has a sheet that I've signed and they've all signed, and that will and hopefully that should just make the marking of the lab sheets more manageable. There's still quite a lot of work to do that, but what I learned from them, I think, is a feasible thing to do. I mean, say the main issue is actually just making sure when I pull off the marks, I can pull off a comma separated list of stuff that I can actually put these names into some system that I can then hack around with Python. Okay, so that's good. The next one, more ambitiously, what I learned there is actually they had some really nice examples where you can actually drop in HTML gadgets. So this is actually one of the applications that I will actually do in one of the computer applications I did that replaced some of the physical experiments that people are keen for me to keep doing. And you can see here actually it's quite simple to actually dump in a little HTML object. So I've just done this very quickly. So this is actually one of the ones we used in the lab. So the thing is, this would be embedded, and then we'd also added Maple TA questions. At the moment, there's no connection between this HTML gadget, which is set by some F-frames thing, and the actual MapleTA. But he had some examples where he actually, for the chemistry people, he had a JavaScript-based library to build up little molecules, and the MapleTA could talk to the library and then pull off information that they could then test against. So this would be another thing. So this is actually one of the computer applications. So now I could actually build in the similar system with other things. I could put in names at the top and a little thing to sign the sheets, and then we can kind of slightly automate more the lab sheets. And since we're on that question, you can also embed. This is Trinket. This is what we use for the. So here I've Trinket.io is a kind of Python-based system. It's a sort of subset of Python, and I've imported it into MapleTA. So this is one of the questions. There's also, I don't think, would talk to MapleTA, and then down here there'll be some questions. Here's my Python source embedded in MapleTA, and then if I run the thing, this is a little bouncing ball example that I think I developed with the Nuffield students. And so you could have a much simpler code, get them to answer simple, run the code, maybe making a few modifications, and then input the answers into MapleTA, or Mobius as it's now known. And the other thing that I learned is they have quite detailed analytics. They're going to update our system the beginning of August, and they have like a dashboard. It's going into something called Google Data Studios. It's all anonymized, and that means we'll get analytics information on how long the students are using the MapleTA system, what's the mean time usage on each assignment, and also you can drill down to an individual question, and it will tell you something that if question 5 they're spending 2 hours on it, and obviously they had some real data. I think it was because it's pre-release, I can't really show anything here, but they had data and there was clearly big spikes in usage very near deadlines, and you could also look at trends. Obviously if one of the questions is taking a lot more time, and you could look at the engagement. There was one really dreadful one where people put a lot of work into the first assignment, and then after that it just gradually decreased. Okay, so I did play around with some of the questions I've never really played around with. There are some things where you can kind of embed different options in an image. You can click on that, and also I played around a little bit with the graph sketching, but not at great length. Okay, so that's my end of my quick report on what I did at MapleTA Bootcamp.